Good morning to all the students. Welcome to the physics class. In the last video, we were discussing about the fundamental forces in nature. So, in that we discussed about the gravitational force and the electromagnetic force. So, we were discussing the electromagnetic force. What is electromagnetic force? So it is the force between two charges. When two charges, suppose one is positive, one is negative, they are placed at some distance, then always there is force between them. Then that force is known as the electrostatic force. So Coulomb made the formula. Coulomb was the scientist. He made the formula for the force between the two charges. Suppose there are Q1, Q2, two charges like this. This is the Q1, this is the Q2. They are placed at a distance R. So, what will be the force between them? So, Coulomb made the formula that the force will be equal to 1 upon may 4 pi epsilon naught Q1, Q2 upon may R square. So, this is the formula made by the Coulomb. So, you can see here easily that the force is equal to 1 upon may 4 pi epsilon naught Q1, Q2 upon may R square. So, if you see here the force here epsilon naught is the permittivity of free space. Just remember this, the name of this quantity, because the elaboration of this quantity will be in the 12th class. For now, you just remember the name of this quantity. Epsilon naught means this is the epsilon naught. Okay, the name of this quantity is epsilon naught, the sign, and the name of quantity is permittivity of free space. The sign name is epsilon naught and the quantity name is permittivity of free space. Q1, Q2 is the charges, R is the distance between them. So, in this manner, we can find out the force between two charges. So, we have also the properties of this force. What are those properties? First property is that आपको जैसे लास्ट वीडियो में मैंने बताया था that the gravitational force always have attractive nature. Means ये attraction ही, इसमें attraction ही होता है, ठीक है, इसमें repulsion नहीं होता. But if we talk about the electromagnetic or electrostatic force, this force have two natures. One is attractive and second is the repulsive. Also, it obeys the inverse square law, as we know that F is equal to 1 upon may 4 pi epsilon naught Q1 Q2 upon may R square. So, this R square force is inversely proportional to R square. This indicates that this obeys the inverse square law. And also it is the long range force. As we know that it depends upon the R. So we can have whatever the value of R, we can find out the force. So that's why it is long range force. It is also central force, as we discussed in the gravitational force. That also central force. It acts along the line of joining the suppose this is the Q1, this is the Q2. तो एक्ट कहाँ पे करेगा? इट विल एक्ट अलॉन्ग द लाइन ज्वाइनिंग टू चार्जेस. तो इस लाइन के अलॉन्ग ये फोर्स जो है एक्ट करेगा. दिस फोर्स इज कंजर्वेटिव फोर्स एंड ऑल्सो इट इज स्ट्रॉन्गर दैन द ग्रेविटेशनल फोर्स. ओके, सो अगर अपनी बात करें, ये जो इलेक्ट्रोस्टैटिक फोर्स है ये कहाँ पे होता है? इफ़ वी सी द डेली एग्जाम्पल, सपोज टीचर इज राइटिंग ऑन द बोर्ड, ठीक है, दिस इज आल्सो एग्जाम्पल ऑफ इलेक्ट्रोस्टैटिक फोर्स, दैट द chalk stick with the blackboard. So that's why which force is acting between the blackboard and the chalk? Because they are attracting each other. The chalk is attracted towards the blackboard. So electrostatic force is between the board and the chalk. So here we can see that the electrostatic force is 10 to raise power 36 times the stronger than the gravitational force. So as we discussed in the last video, that gravitational force is due to exchange of a particle known as graviton. So this force is due to the exchange of particle. The name of the particle is photon. Always remember, gravitational force is due to exchange of graviton, and this force, electrostatic force, is due to exchange of particle photon. There are few examples of electrostatic force we can see here. One is this is between the molecules of any material. Suppose we press the rubber, so there will be the electrostatic force between the two molecules. So that's why after removal of the force, rubber will gain the original position and size. So what is the force there? The force is the electrostatic force. As we have another example of spring. When spring is compressed, it exerts a force of elasticity due to net repulsion attraction between the neighboring atoms. Okay, when we try to compress the spring, so it tries to expand. ठीक है, ये हमें अपोज करेगा कि जब हम स्प्रिंग को दबाएंगे, कंप्रेस करेंगे, देन इट विल ट्राई टू एक्सपैंड. ये हमें अपोज करेगा. सो व्हाई इट इज अपोजिंग? इट इज अपोजिंग ड्यू टू द इलेक्ट्रोस्टैटिक फोर्स बिटवीन द एटम्स. This we will study further and deeply in the chapter of mechanical properties of solids. This will study in the deep. Now next topic, our next topic is laws of conservation. We have many laws of conservation, like we have conservation of energy, we have conservation of momentum, angular momentum, charge. So likewise, these are some laws of conservation. So basically, the laws of conservation is the, in any physical process involving different forces, some physical quantities remain unchanged with time. Such quantities are called conserved quantities, and laws which are governing these conservation of these quantities are called conservation laws. So there are some of the laws, like conservation of energy, conservation of momentum, angular momentum, charge. So these we will discuss in the next video. Thanks for attending the class.